I'm going to start with a couple of words of introduction from Rachel Kuski, the chair of the School of Mathematics, and Steve French, the dean of the College of Design.
Thank you. We're here to celebrate today, to be inspired by the Seven Bridges of Konisberg. This is a classic puzzle of the 18th century that asks, is it possible to cross all of the 7 bridges of the city of Konisberg exactly once with no repetition or backtracking? And here at Georgia Tech you have the chance to actually solve the problem, because we have the 7 bridges represented here with the white bridges across the light blue walkway, which is representing the river, and the islands and land of the city in the gray. So you can test that out. But in the 18th century, Leonard Euler, one of the giants of mathematics and science, actually answered the question with no, but in seeking the answer, it led him to think more generally and actually found new fields of mathematics in topology, or the geometry, with connectedness, and with graph theory, which is also network theory. And so Euler was not just content to say yes or no to this problem, but to think more broadly in a mathematical way and say, can we say things about bridges in other cities with different islands and different bridges? And that, of course, leads on to what does that say about different types of networks in terms of transportation or communication, in terms of how do we spread ideas on Facebook, how do diseases spread, and that leads us to the connectedness in our world today. So being inspired by that, we have Georgia Tech's School of Music and the School of Mathematics teaming up with local Atlanta artists to create this performance that will celebrate the 7 bridges of Konisberg. Thinking about this history, piquing all of your curiosity, I hope, and also conveying the wonder of mathematics. Now, this project was one of 10 inaugural awards in a program called Science in Vivo, funded by the Simons Foundation. And this is an experimental site that's, quote, exploring what is possible when science experiences for the public are integrated into existing cultural gatherings. And so we have a chance to do this right on this site here at Georgia Tech now. This is the debut performance. There'll be another performance at Kennesaw State on the 23rd, and then other versions of the show will actually tour around in Atlanta and in the southeast region over the next couple of months. So I'd like to also acknowledge, besides Science in Vivo, funding also from Georgia Tech College of Design, the Georgia Tech Office of Arts, the College of Sciences, and also to recognize that this is a production of Georgia Tech Music with the assistance of Mathematics in Motion Incorporated. And thanks to our own Professor Evans Harrell for his vision and energy, and our Club Math, who have done the lead up and participation in this event. And so now I'd like to turn it over to the Dean of the College of Design, Steve French, also where we have the home of the School of Music.
Thank you, Rachel. Welcome to the new plaza here, the 7 Bridges Plaza. We're thrilled by this collaboration between the School of Music and the School of Mathematics. The Georgia Tech Symphonic Orchestra, conducted by Professor Chow Ting, will perform a new piece of music that was written especially for this occasion. We'll also be joined by a choreography of a number of dancers who will interpret this music as well as the Bridges Plaza here. The Symphonic Orchestra includes students from all across Georgia Tech and reflects the breadth, creativity, and passion of our Georgia Tech students. The composer of this new piece, Marshall Coates, says that the music of the 7 Bridges reflects the struggle against futility. I hope that's not something that Georgia Tech students are particularly familiar with. The original 7 Bridges problem had no solution and none could be found, yet the problem generated, as Rachel just said, an entire field of mathematics. The composer used this idea of the struggle against futility as the inspiration for his work. He believes that everyone can identify with this kind of mental struggle, yet face it with determination. The piece opens with an exploratory mind theme. You'll hear the mental cogs turning through different kinds of instruments, which give way to a more harmonious structure. The middle section is about working out the puzzle with moments of sublime realization, and the later section is a blend of excitement of discovery coupled by the frustration of futility. I hope you enjoy this unique artistic creation and performance, as well as the plaza.
Thank you, Rachel and Steve. Did you ever look at a stream and wonder how the water will flow and swirl and why? Or wonder why the football will spin and wobble in its flight in just that way when the quarterback throws it? Or ask yourself how the sound waves carrying words and music through the air and into your ears can arrive without getting all mushed up and distorted. Scientists have powerful mathematical tools to address questions of these kinds about the workings of our world. For the flow of water, we call on Euler's equations. We describe the wobbling of the football with Euler's angles. And we solve the equation for the waves of sound using an innovative solution due to Euler. So who was this Leonhard Euler that we're celebrating today and who's commemorated on this plaza for one of his many achievements? Euler may be the most prolific scientist of all time. He was a man who could look at any practical problem of his day and use it to transform a branch of science. But Euler also loved puzzles, and he could be captivated by a little conundrum, such as whether it's possible to walk over all of these 7 bridges in the city of Konisberg exactly once. A puzzle can hide within it a simple logic that will amaze with its beauty. And the beauty that Euler saw in the puzzle of the 7 bridges of Konisberg led him to found an entirely new branch of mathematics devoted to networks, which we know today as graph theory. Graph theory is the science of connections. So let's take a moment and think about our connections at the personal level with the people around you, to your right and to your left. Did you see them earlier today in a class? Do you drive the same kind of car? Do you have the same brand preference about your laptop or your phone or your sneakers? Could you once have caught a cold from one of those people? Well, today, the quickest way we make connections with people is online through social media. In fact, we can do that right now. If you have a smartphone, just take it out, open Instagram, and type in our handle, which you can see around this plaza in a couple of different directions, and click follow. If you do that, we've been instantly connected. We've created a new network, the Graph of Followers of 7 Bridges ATL. Today, networks permeate our world. Graph theory plays an essential role now in fields from computer science to particle physics to biochemistry. And closer to home, anytime you launch a web browser, or like a post on our Instagram, or make an airline reservation, or find a ride on Uber, or find a bird scooter, you are living a life shaped by graph theory. We now go back in our imaginations to a time long before Instagram, to 18th century Russia. Our protagonist is bouncing one of his young children on his knee while thinking intensely about the puzzle of the 7 bridges of Konisberg. He looks especially at the island at the center of the city, and he sees that it has 5 bridges connecting to the other parts of the city. To Euler, the only thing that matters is the connections. And the number 5 strikes Euler as odd. And then the other island connects to 3 bridges. And there are 2 other pieces of the city along the banks of the river, and each of them has 3 connections. Euler thinks that those numbers, 5, 3, 3, and 3, have a message. But for now, I'm just going to leave Euler and you, if you're trying to solve the puzzle in your mind, with that odd clue to the 7 bridges of Konisberg. It's not recorded how Euler learned of the puzzle of the 7 bridges of Konisberg, but it could easily have happened when he was traveling to nearby St. Petersburg, the one in Russia, on his way to his first academic job. For you see, after Euler's brilliant dissertation on the physics of sound, he was unable to find a professorship in his native Switzerland. And his friend Daniel Bernoulli saved Euler's career by arranging a position at the faraway Petersburg Academy, which had been founded by Tsar Peter the Great only a few years earlier. Euler's life continued to be full of challenges and obstacles. Many of his 12 children died in infancy. His poor eyesight eventually failed so completely that he had to continue his copious researches by dictating them to a team of assistants. And political turmoil was frequent in Euler's day. In fact, his patrons, Catherine the Great and Frederick the Great of Prussia, actually went to war just at the height of Euler's career. Somehow, Euler carried on and made endless new discoveries. He may have learned a lesson about persistence from trying to solve the puzzle of the 7 bridges. If you tried to walk these bridges or solve the puzzle on a piece of paper, you may have found it difficult and had a feeling of futility. You may have been inclined to just say, oh, it's too hard, and I'll let it go at that. But to Euler, Koenigsberg was just the example that sparked the contemplation of the infinite possibilities of any city with any number of islands and bridges that have been connected. Koenigsberg may have vanished from the map today, And the puzzle in its setting may not have a positive solution, but the story of the seven bridges has inspired thinkers for centuries and has bequeathed us the connected modern world. This show was a teamwork at many, many levels, and it's been wonderful to work with such a creative and talented team of musicians and artists. It's also been great to have the support and help of people from all across the campus, from the building managers to administrators of many kinds. Seven Bridges of Koenigsberg was first and foremost a collaboration of two SOMs on campus, the School of Music and the School of Mathematics. And we'd like to thank particularly their chairs, Jason Freeman and Rachel Kuski, for their personal support and the financial support of their schools, as well as the financial support of the colleges of design and sciences to which they belong. We also have, with much gratitude, the sponsorship of the Office of the Arts, led by Madison Cario on this campus, and our outside sponsor, Science in Vivo. And what makes Georgia Tech really special is, of course, its students, especially the many student volunteers, including Club Math, orchestra officers, and the GT marching band props and lieutenants who provided much essential help during this performance. Thank you, one and all.